Hi everyone and welcome to a brand new video. Today we'll be tackling the three sum closest problem, which is the problem on the screen, which is when you're given an array and you need to find the sum of three integers inside this array that is closest to target. So there is another problem in which you need to find the sum of the numbers which add up to target, but this one's a little different because you need to find the closest sum. So in order to do this, what we're going to do is we're going to do a two-pointer strategy, which is super similar to binary search, but what we're going to do is that we're going to have integer. We're going to have I, and that's going to be iterating through the array. And then, so for the remaining portion of the array, so let's say I equals 1. So from 2 to nums.length minus 1, we're going to set 2 here to be low, so that's going to be another pointer, and we're going to set this to be high, another pointer. So we're going to have these three pointers, and we're going to be taking the sum and see whether or not it's closest to target. And the reason we're doing this instead of having 3 for loops is because it makes our O log time from around O and 3 to around O and n squared. So let's test that out. So what we're going to first want to do, like all binary search algorithms, is that you have to sort the array first, and then we're going to create that single for loop with I. So we're going to say for int I equals 0, I is less than nums.length, I plus plus. We're going to set int low to be I plus 1 and int high to be nums.length minus 1. And what we can do is that we can say while low is less than high, this is where we'll run our code. So we'll be int sum is equal to nums.I plus nums.low plus nums.high. And then here we also want to keep track of the difference between target and sum because we need to find basically the lowest difference. So what I'm going to do is we're going to say int diff is equal to integer.max value. And by doing this, what we can do is we can say if maths.ab, so the absolute value of target minus sum is less than maths.abs of diff, then we're just going to set diff equals to target minus sum. And the reason we're doing this is because we don't care about whether it's negative or positive, which means we don't care about whether if we have two values, we have sum is negative 2, sum is positive 2. Positive 3. No, this would be negative 1. So they're both 2 away from target, so they would be equally valued. Then we're going to set diff is equal to target minus sum. And then over here inside this for loop, we're going to say that and we're going to set if div not equal to 0. Because if div's equal to 0, then that's the most ideal situation. We can just leave the for loop. There is one problem with this code though, beside the fact that we haven't returned anything yet, is that we're not changing the values of low and high, which is an infinite while loop, and obviously we don't want that. So what we're going to do is we're going to say if sum is less than target, which means that sum is -1 in this example, then we're just going to increase low by 1. And else we're just going to decrease high by 1. So what that's going to do is it's going to change our pointers so that we can find the most ideal difference. And then at the end, all we need to do is do target minus difference. So when we run our code, I just took the code from the notepad. Let's actually test this out. So we can see that we get 2, which is the answer. So hopefully this helps you solve the sum 3 closest problem with some level of efficiency instead of having this really long, time-consuming program. See you in the next video. Bye.